Hello everyone, this is Stas and welcome to my new TouchDesigner tutorial. And today I want to show you a trick how to convert SOP to top in more efficient way. More efficient compared to standard approach like converting from SOP to CHOP and from CHOP to top. And I'm not gonna lie, this is not something you would use very frequently because usually you don't need to convert SOP to top and then render it as a point cloud or something. And even if you do so, usually the SOPs is stable, but sometimes, for example, if you use a connect with metaballs or some complex geometry when some parts are moving and other not, you already spend a lot of CPU resources on a SOP level and you would like to spend as less as possible to convert it to the top. And this trick came to my mind last week when I worked on another tutorial that will be ready soon about strange and non-obvious using of sprinkle SOP. And I just thought, could I render a SOP as instances and then use it as a point cloud? And I did, and I checked the performance difference and it was quite good. Let me show you. Here on the second base, let me switch, it switched to the second base. And here you could see my FPS and CPU. This is pretty low because this approach is pretty made up. I just use the transform. It's usually you never should do this because it's better to rotate your geometry after converting it to the top or on geometry level. But to demonstration purposes, this is fine. Okay, so I have a pretty low FPS and pretty high CPU time. And let me lock this 10 seconds trail data. This is average. And now if I switch to my new way of converting and reset this, let's wait 10 seconds until it goes and compare the results. But you already could see that we have a pretty significant increasing of FPS and decreasing of CPU time. So, if you're just interested in using this approach, you could support me on Patreon and download it, or we could do it right now from scratch. I'm not gonna repeat all of this because this is just using some SOP data, and this is normal rendering like instance and the position. So nothing interesting here. The most interesting part is this base. Here is our standard approach, like we have a SOP, then convert it to the SOP to CHOP, and then render it, convert it a CHOP to SOP as RGB, and fill extra pixel data with something. And we'll explain about this GLSL a bit later. And let's make my new method of doing this. Let's make a base, and to speed up things a little bit, I switch off this transform for now. We don't need out. Here we have our input, and I want to know how much points did I have. I have a number of points like 200,000. Okay. And what I want to do is I want to render it as a grid and to use this SOP as a positional data. So I want to know what size of a grid should be, and to do this I could use a math. I could square root of it, and I want to be the grid is the same point size or a little bit more, so I will integer it with a scaling mode. So now if I have a grid and put it as a number of rows and number of columns, I have a little bit more than this amount of points. And I will use it as a positions for our instances. And let me illustrate it to what I want to do. I want to create a grid. Let me do it super simple grid. And I want to render rectangles on it, like rectangle, 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 and so on. And color these rectangles as a position of incoming SOP. So we need this. Next we need a rectangle. And I will render this rectangle as a geometry. I need only camera, I don't need light here, and I will use the constant material and render. Alright. And I want the final render would be the same amount of pixels as we have rows and columns. So let me use this number to resolution. And of course it should be such, because this is a positional, we want to be this very precise, so nearest pixel, 32 bits float, and we don't need any dithering and we don't need any anti-aliasing. Alright. Now we need to calculate the size of this rectangle, and this is very simple. We just divide 1 by this number. So because we want the final square to have size 1 by 1. And also in the camera settings we don't need any perspective distortion, so we will use the orthographic camera, and ortho width is equal to 1. Right now we have only one very tiny pixel, and let's use our position as P, and you could see probably the small issue here, because if you look at this, what we have here, we have the grid size 1 by 1, so we have this size equals to 1. But what we want this size equal to 1. So how to calculate this? This means that we want we need to, how to calculate the size of a grid. We want 1 minus 1 of these pixels, so minus 1 divided by, in this case, divided by 4, or in general case divided by n. So let's take this, and size 1 minus 1 divided by this number. Right, and now it should be fine, and let's try to see it. If I increase the ortho width a little bit, you could see that only at exactly 1 we have exactly full render. Alright, now we want to use this as a color, right? Almost. If we now put this as an instance for our color, it wouldn't work. P2, because all operators should generate the same number of instances. And now here we have this number of points, and here we have another number of points. So what we need to do, we could use the expression chop, and as an expression we could multiply this value on itself, so it would be a square number minus this value. And actually I forgot to do one very important thing, and let me show you. If I turn on rotation again, you could see that this chop is cooking all the time, and we don't want this, because if it's cook all the time, our grid would be created every frame again, and this would be decrease our CPU. So no, it will increase our CPU time, so it will decrease our FPS. So what we could do is we could paste a null here, or actually we could do it here. It should work. Let me test it. I never done this before. So if I set cook type to selective, now you could see that this is cooking. Probably you'll see it on YouTube, maybe not, but anyway, this, as you could see, the total cooks increases, but this is stable, so it's not cooking, and of course this is not cooking also, and this is very good for our purposes. Okay, so back to the expression. Input value multiplied by input value minus operator math1 and math1, and we need channel 0. Oh, something not working here. Why is not working? Oh, yeah, of course. It's not operator math1, it's operator null1. Null1. Okay, so we need to create extra 704 points. So let's add a point, and let's copy it 704 times. Let's copy, and the number of copies would be this one. And if we now switch to merge, everything should work fine. Okay, let me turn off this again. Now let's output this, and we will need to do one more thing, because right now if I switch to this input, and if I again translate it, you will see this extra instance at the 000 position. Why is this? Because all of our extra points added to the position 000. We could do it switch to some other position like 999, 999, 999, and now it's invisible, but this creates another not very good issue, because here if I set, for example, home all, now we have very ugly scale because our extra instance is somewhere over here. And let's create a very easy GLSL to eliminate this. Let's do GLSL, and we want to, the extra value we want to reject, we call it uReject, and here the best way how to choose this position, it should be the same value that you for sure wouldn't have in your geometry. Maybe your geometry will have the point at this exact position. But probably if I set something like this, the chances that you will have a point at 99.9 exactly position is pretty low. So I prefer to set something ridiculous here. And let me paste it, paste reference, and this is to 0. And let's edit. Okay. So output the frag color. We need to pass uniform, we call it uReject. Uniform vec3, because we have 3 XYZ values. All right. And let's say we have as an input our texture that coming in at, well, RGB, and as output I will set the input position, and the alpha value would be equals to 1. And right now something it's not working. What's not working? Of course our input is vec3. So let's see. Right now we have, I press the D, and our extra, the value is 99.9 on all 3 channels. And now I could set a very simple condition. If inputs equals to uReject, then this is very stupid, but it works. We divide it by 0. As you know from school, you shouldn't divide by 0. It's illegal in mathematics or something like that. And yeah, I mistype. And now if you check the same position, instead of 99.9, you get an error like inf. Here you could see on the red, for example, you get this inf. In GLSL we have the inf or none, which is wouldn't be rendered here in our final renderer. So that's all we need to do. And by the way, you could use the same trick even if you use the standard approach. Here is GLSL exactly for that, the same. And let me also show you in initial position, and you could find it on the Patreon. I tried to use custom GLSL when I do super minimal GLSL, because I thought maybe it will do a little bit more improvement to me in terms of performance. But I found out that it's almost not true. Let me first, for example, measure my original one, is this one, with GLSL. Let's pulse, just to check. Okay, almost done, and okay, we lock it. And now let's switch to the base that we created right now, and again reset. And as you could see, the performance it's about the same, so there is almost no reason to do extra step than creating custom GLSL. You could use the constant GLSL and have about the same performance as I got with custom one. And that's all for today, and I hope you find this useful for your work, and also I hope next week will be not so busy and I finally finish my tutorial about unusual ways of using Sprinkle, and see you next time. Bye bye.